So this is my work for Quideo number 2 on the basic question, and this data was collected in a women's weight gain study, and it evaluated the relationship between how many calories were burnt in 24 hours, or the metabolic rate, and how much lean body mass in kilograms that each of the women had. So the question asked you just to graph a scatter plot, so I plugged it into my calculator, and this is the pattern that I got. And so it shows a linear relationship because of how it goes up and down the paper like that. And it's positive because both of them increase as it goes from left to right. So from this we can say that the more calories a woman burns in 24 hours, so the higher her metabolic rate is, the more lean body mass that she has. So yeah. So this is my work for the advanced question on Quideo number 2, and this collected data from a test on boys that walked on a hard surface for 6 minutes, and they tested 5 different age groups, and so here are the age groups, and here are the representative ages, so the midpoints. So for my graph, I used the median, or I plotted the midpoints for each of the age groups instead of using the ranges, because that would be more exact and it would help getting the least square regression line and finding that making that easier to find. So I plotted on the y-axis the distance in meters for how far the boys walked, and then on the bottom is the age, and so in the blue is the least square regression line. And then question A said determine the least square regression line and its slope. So when you plug all of the information into your calculator and you find the predicted y equals a plus bx, you got 4.492.7977 plus 14.7633x equals is for your line. And so this value is the slope, so b equals 14.7633. And because each of the age groups increased by 1 year, we can predict that the median walking distance will increase by the number in the slope, or the b position in the equation. And yep. Okay, so this is part B of the advanced question. And so I have the same axes for part B that I had for part A, because all that we are doing on this is plotting the residuals of the data that we just plotted in this part of the advanced question. So I have 5 residuals: negative 16.17, negative 12.14, negative 7.551, 8.9974, and 26.867. And so those are all plotted here. And so for the description of the data, I said that it was unusual because there wasn't really a lot of consistency or a pattern in the residuals, like there was in the regular data set and the least square regression line, like in part A. So it's difficult to accurately make conclusions about the data when you have negative distances for the test, and then also because there really is no correlation that shows through here accurately like it would for the other set. So yeah. And lastly, I have the AP question. So just to refresh your memory, here is the scatter plot for the data on commercial airlines, and here are some of the variables for the equations. So here's my work, and so the first part of the question asked for to identify the equation for the least square regression line, which is right there, and what the variables were. So the 1136 number is going to be the constant coefficient for the data. And that was just found in this chart and plugged right in to your calculator for the equation. And then my y and my x are the operating costs. Per hour is y, and then x is the number of passenger seats on a commercial airline. And yeah, so then B asked for you to find the correlation coefficient, which is R. And so for that, you would take the R squared percentage of 57%, and you would take the square root of that. And so that gives you 0.755. And so R is 0.755, which is positive. And so the scatter plot, when you go back to it, you can kind of double check this by looking at where the individuals fall in the scatter plot, and you can see that they do both variables increase together. So they have a positive correlation, and there is a moderate to strong correlation between the two variables, because they all are going in the same direction, and yet they somewhat fall right around this least squares regression line. And then part C asked if you wanted to describe the operating cost per hour and the number of passengers in the planes for only the range of 250 to 350 seats. So when we look at the scatter plot, we can see the range, and so I did 250, and this is actually the 350 mark, not the second yellow line. And then I kind of just focused on these points. And so you can kind of draw a line like right down the middle of roughly what their least squares regression line would be. And so from that you can predict that that area of the range of 250 to 350 passengers would have a negative least squares regression line because it has a negative correlation. And the 3 points above the line, and this is what supports the case. So the 3 points above the line all have high x values, or high y values but low x values, and then vice versa for these 4 points below the least square regression line, the original one. And so that kind of justifies why they have a negative correlation. So that's it.